So, I have written the fundamental theorem of calculus here again. You could write it if you want, but you don't necessarily need to for this problem, for these notes, because they are just on those notes we just took. But whenever we integrate f of x dx from a to b, we will get capital F of b minus capital F of a, where that capital F of x is the integral of our f of x. So, if we want to integrate example 1, we're just going to integrate like we were doing the other problems. And so we'll have x to the third, and then we'll have 4 divided by 3. So just using that power rule to integrate. And then we'll have minus 2x plus c. And then I'm going to draw that thing that I was drawing, just this bracket here on the end. Sometimes some books use just a bar and some use a bracket, and from 0 to 3. Okay, so now what I need to do is find, this is my integral. Now I need to find that capital F of 3 minus the capital F of 0. So I would plug in 3 to my equation. 4 thirds times 3 to the third minus 2 times 3. You're not plugging anything in for c because it's just a dummy variable. And then we would subtract 4 thirds times 0 to the third minus 2 times 0 plus c. And then you're just going to evaluate that. So 4 thirds times 3 to the third, one of those 3's is going to cancel out. So one of those 3's will cancel and just make that squared. So that's going to be 4 times 9, which is 36, minus 6 plus c. Over here, you just get 0 plus c. We just got a c there. So we've got 30 plus c minus c. And what happens with the plus c minus c? It cancels. Okay, so we just get 30 for our answer. Okay, a little note here. The c's will always cancel for definite intervals. So you do not have to include them. Now, with indefinite integrals, the ones you guys were doing last night, where you were integrating and there were no limits on your integration, you have to put the plus c. And if you don't put the plus c on the AP exam, if it's free response, you're not going to get some points for that. And when we do differential equations, it's going to be even more important that you put the plus c. However, if you were doing a definite integral, you're always going to have a plus c right here, but then this minus c over here, and they always cancel out no matter what type of equation you've got. So whenever you're doing definite integrals, you don't have to put the plus c right here. I did for this one, and if you do, it's fine, but you're just adding extra work in there. But I did mostly because I wanted you to see that it will cancel every time. Okay, questions? Alrighty. Now, we're not going to copy all this down. This is in your book. If you look in your book at the front cover, you will see I have put these side by side because the derivative of sine is cosine, so the integral of cosine is sine. The derivative of cosine is negative sine, so the integral of sine is negative cosine. Notice signs are switched here, so integral of cosine is positive sine. The integral of sine is negative cosine. So I put them side by side so that you see how they relate. But you really kind of already know most of these because you know the derivative rules, hopefully, anyway. So if you know the derivative rules, the integral rules are just the opposite of them. So if you know that the derivative of tangent is secant squared, well, the integral of secant squared is tangent. Right? If you know the derivative of secant is secant tangent, then the integral of secant tangent is secant. There. The ones that have negatives, they have, instead of doing integral of negative cosecant squared x, they have done integral of cosecant squared x, so you get negative cotangent. We don't use these like last ones a lot, but you might use them some, so they're here. But these are in your book. They're somewhere else in your book too, but I know they're in the front cover, so you can see those there. So as you go through your homework tonight, you might need to you might want to take a picture of that front cover of your book, or right, not front cover, but right here on the very first inside page, so that you've got those there. Since I'm not having you guys write those down. So let's do this example. Integral from 0 to pi of sine x over cosine squared x. We do not know how to do this equation as it is right now because it's got a fraction. We can't do like a love connection or anything here because this is a totally different type of problem. So as it is right now, we cannot integrate that. We definitely cannot integrate top and bottom separately. Plus, we could, even if we could do that separately, we cannot integrate a cosine squared x because we don't know what that is. But what we can do for this one is we could write it this way. Integral from 0 to pi of sine x over cosine x times cosine x dx. What is sine x over cosine x? It's tangent. And then I could write it like this. I could make this 1 over cosine x, because if I multiply those back together, I'd get sine x over cosine squared x. And what is cosine, or 1 over cosine x? Is secant. So what we have here is we have the integral from 0 to pi of tangent x times secant x dx. And this is probably not one you remember the rules for very well, but if you look in that front cover of your book, or I'm going to flip back here, the integral of secant x tangent x is secant x. Okay? So, or we've got tangent x, secant x, but it's the same thing. So what we get when we integrate this here is just secant of x, and we're evaluating that from 0 to pi. And I would probably even do this. Secant x is 1 over cosine x. And we're integrating that from 0 to pi. And I would do that because I don't know the unit circle values for secant. And so we would have 1 over cosine of pi minus 1 over cosine of 0. What is cosine of pi? What? Negative 1, yes. And then, what is cosine of 0? It is 1. So we end up with negative 1 minus 1, and we get negative 2 as our answer. There. Okay. So you'll have some that have some trig in them. Use those integrals there. You will not have any really terribly difficult ones. This will be one of the more difficult ones you'll have. Okay. We also have to know about the integrals of logs. Such drama. Start on homework then. You're sick? Yes or no? Alright, just start on homework. He's getting old. He's 9 years old now. Life's tough. You know. So I put the derivative rule here just because to remind us that the derivative of the natural log of x is 1 over x. So if we integrate 1 over x dx, then we would get the natural log of the absolute value of x plus c. The absolute value bars are there because we cannot take the natural log of a negative number. So that we have to put the absolute value bars there. So this first example, I don't have 1 over x, but I've got 2 over x, which I could think of as 2 times 1 over x dx. So when I integrate that 1 over x, I get natural log. This 2 is just a coefficient. So I would get 2, I meant to put definite integrals on this, but I forgot to do that. But that's okay. We just need a little practice with this. So 2 natural log of the absolute value of x plus c. These are supposed to be definite integrals. I forgot to put them on these when I was making these notes. But since we don't have definite integrals, we don't have the limits, we're just going to put the plus c on the end and be done. Okay. If we look at example 4, it initially does not really look like it's a natural log problem. But what you would have to do here is you would have to do the love connections. And so this would be the integral of 3 plus 5 over x minus, I'm going to write this as 2x to the negative 2. And actually, let me just go ahead and write them all as negative exponents. So, plus 5x to the negative 1. Whenever it looks like this, you probably don't even recognize that it's going to be a natural log either. So if you just start doing this problem with just the general power rule, you would have 3x, and right here's where you run into trouble. Because if we use the general power rule on 5x to the negative 1, we have to add 1 to the exponent, right? That gives us x to the 0. Then what do we have to do? Divide by 0, but can we do that? No, we cannot do that. So that should be like the alarm going off in your brain telling you that you can't actually do this. This is 5 over x, and the integral of 5 over x would be 5 natural log of the absolute value of x. So if you find yourself doing that power rule and you're having to divide by 0, then it's really supposed to be natural log for that one. And then the last one we can use the power rule on, we'd have x to the negative 1, and we divide out front by negative 1, which would give us a positive 2, and we put a plus c over here on the end. Okay, questions? All right, we got one more thing that's really super quick. The integral of e to the x dx is e to the x, right? Because the derivative of e to the x is e to the x. So we probably won't have time to do both of these, but I'm just going to go ahead and do this one problem. If we have e to the x over 5, when we integrate it, we still get e to the x over 5. That over 5 is just a coefficient, so it's just going to stay. And so if we were evaluating this from -2 to 3, we would have e to the third over 5 minus e to the -2 over 5. And they might put some stuff together there or not. We're just going to leave it like that. And I don't have time to do the last problem, but when you have that, the integral of 5e to the x would be 5e to the x. So it's really the most simple of all of the integrals that you will do. So the assignment that I want you to do tonight that goes with this is on page 328. And you're going to do 5 through 29 odd, and 37, 47, and 48. Okay. You may use your calculator just to do the numbers, like add, subtract, multiply, divide. Please do not use the calculator to take the integral unless you just want to do so to check your work.